You are listening to Ship It, a podcast about operations, infrastructure, and the people that are Kuberneting, Kasich, you know what I mean. I'm your host, Gerhard Lazu, and in this episode, I'm joined by Tammer Saleh, founder of SuperOrbital and former VP of Engineering at Pivotal. Many years ago, we both used to work in the same London office on CloudFoundry, and nowadays, we are into Kubernetes. We start with table tennis, remote work, and then we spend the rest of the time talking about the challenges that teams have with Kubernetes. Tammer and his SuperOrbital team are deeply experienced in this topic, and they help teams at companies like Bloomberg, Shopify, and federal US agencies tackle hard Kubernetes and DevOps problems through engineering and training. So why do companies need Kubernetes in the first place? Which are the right reasons for choosing it? Is Kubernetes even a platform? My favorite, I'm doing Kubernetes wrong, but it works better than when I was doing it right. So what's up with that? This last one was a lot of fun. And, as your request, we left the entire minute of laughter in. Big thanks to our partners Fastly, LaunchDarkly, and Linode. Thank you for the great bandwidth, Fastly. You can learn more at fastly.com. Ship new features with confidence by getting your feature flags powered by launchdarkly.com. And thank you, Linode, for keeping our Kubernetes fast and simple. Run your setup as we do via linode.com/changelog.
This episode is brought to you by Honeycomb. Honeycomb is built on the belief that there's a more efficient way to understand exactly what is happening in production right now. When production is running slow, it's hard to know exactly where problems originate. Is it your application code, your users, or the underlying systems? Teams who don't use Honeycomb scroll through endless dashboards guessing at what they mean. They deal with alert floods, guessing which ones matter, and go from tool to tool to tool, guessing at how the puzzle pieces all fit together. It's this context switching and tool sprawl that is slowly killing your teams and your business. With Honeycomb, you get a fast, unified, and clear understanding of the one thing driving your business: production. Honeycomb quickly shows you the correct source of issues, discover hidden problems, even in the most complex stacks, understand why your app feels slow to only some users. With Honeycomb, you guess less and know more. Join the swarm and try Honeycomb free today at honeycomb.io/changelog. Again, honeycomb.io/changelog.
We are going to ship in 3, 2, 1.
Several years since we worked together, 2016, 2017, and I think it's been too long since you and me played the game of table tennis. How's your game these days?
I was so bad at table tennis.
That's not true. I've seen the improvement. I've seen those years in which you really improved. And the last games that we've had were really good. So I enjoyed them.
It was a lot of fun. I don't know if you know this. It was never official, but it always kind of seemed like your seniority at Pivotal would directly correlate with how good you were at table tennis.
Yes. I knew that, but I never mentioned it to anyone. I think it was like a little thing, yes.
I'm pretty sure most of my engineers let me win just to make me feel better.
I'm sorry, not me. No, we had some great games. So did you play much in the last 3-4 years?
Not at all. Yeah. I mean, it was entirely a Pivotal thing. It was like part of built into the Pivotal culture. You know, you're pair programming and you need a quick 15-minute break where you get up and you jump around and there's table tennis tables right there and you're playing doubles. So you're a pair, you find another pair that also needs a break. I mean, everything about it was just built around Pivotal.
Yeah, I really miss that. Like from the whole office culture, which seems to be slowly disappearing when it comes to remote work. And, you know, this is like the new norm and we're in it for the long drive, shall I say. I really miss that table tennis, that social aspect. That, I mean, pairing is great. You can do it remotely, but what you can't do remotely is play table tennis.
It's true. I mean, I've always been very passionately 100% remote. Our company has always been 100% remote. even before the apocalypse. And that made the apocalypse a little bit easier for us to weather as a company. But I do miss that camaraderie of going out to lunch together, that camaraderie of playing a game of table tennis together. And obviously, there's a tax to being remote when it comes to communication, right? Communication is just more fluid when you're sitting right there. At the same time, there's always benefits one side or the other. And I think the benefits of being able to find amazing talent who's uninterested in moving to some central location, and the benefit of everyone in the company being on equal footing. You know, the companies that do remote where there's a mothership and small offices, the small offices always feel like their growth is going to be stunted. And it is, because they're not close to leadership and close to where the decisions are made. And even more important, and I think this is more of about American culture and what's been happening to American culture over the past, 20, 30, 40 years, as people congregate more into the cities. We are getting a very strong cultural divide. It's probably happening other places too, but for us, it's incredibly strong between the cities and the countryside, right? And I feel like the more fully remote various companies move towards, the better it's going to be for society, because you get people from different backgrounds all working together, and you start to flatten out the cities. I think cities are not a great thing from a cultural point of view, right? They're a huge strain on infrastructure, and it would just be much better if we could just flatten them a bit and have the small towns grow a bit bigger in the countrysides. And I think fully remote allows that.
Yeah, I can see that. And I do have to say, having left a big city not that long ago, I'm still around it. I'm still around London, but I'm not living in London anymore. And I do appreciate the advantages to that. But I can also see some of the trade-offs. So there's always some trade-offs.
We missed the really good dinners.
And the table tennis.
Yeah.
Okay. Now, one other topic that I know that you're really passionate about besides dinners and table tennis is Kubernetes.
It's true.
Same here. Big fans. So I know that you're seeing so many things around Kubernetes, so many social interactions, so many teams interacting with Kubernetes.
Yep.
And I see companies these days, they no longer say, oh, Kubernetes is interesting, maybe I should try it out. They need Kubernetes. And that's a very interesting mind shift, which happened, I think, in the last maybe year, 2 years. So a company, when they start with Kubernetes, what problems do you see them having?
Yeah, that's a great question. And just to put a little bit of context in it, so at SuperOrbital, we have kind of two lines of business. One of the lines of business is, the biggest one is our engineering services. We help companies out with very difficult Kubernetes-related problems. We have, a very small team of very senior, seasoned engineers with a lot of judgment. And when one of our clients has a very unusual and challenging problem with Kubernetes, like going on premise via Kubernetes or doing some very deep security stuff with Kubernetes, that's when they bring us on board for short-term engagements, whatever. We help out. We also have a smaller part of our business, which is producing workshops and training. And the reason that I bring this up is because when we are doing our workshops, that's when we engage more with companies who are just starting to embrace Kubernetes, right? So we don't help those customers on the engineering front as often, but more likely we get to train them and show them how complex Kubernetes is. That's the key problem with Kubernetes. I mean, everybody who's used it knows it, but the complexity is huge. I mean, there's something like 80 different resource types that the Kubernetes API understands the last time I looked. And each one of those can have dozens or hundreds of attributes that you have to some degree, understand. And especially as you're doing production workloads in Kubernetes, the defaults are not always in your favor, right? So things like affinity rules and stuff, which this stuff is improving, but affinity rules, security, all that stuff is things that are kind of left as an exercise to the reader with Kubernetes. And so the complexity is just enormous. And new releases, they used to happen quarterly, and now literally slowed it down because quarterly was too fast. So now it's every 3 3 times a year, new releases. Sure, it's a minor number, but we all know that in Kubernetes world, like the minors are basically majors, right? Mm-hmm. So, 1.23 is around the corner right now. By the time this is published, it'll probably be out. Yeah. And the interesting thing to me is that the original authors of Kubernetes, they never envisioned that Kubernetes would be used directly by application developers. That's fascinating to me, right? There's some tweet by Joe Beda where he said that they always viewed YAML as an implementation detail, as like the assembly language or whatever, the API that you would talk to Kubernetes via, and there would always be something on top of it that would smooth over the rough edges and take care of a lot of that complexity and make all those decisions for the developers, for the engineers. But yet here we are, right? We are all wrangling YAML in order to use Kubernetes. So absolutely, when we train our customers in Kubernetes, our most popular workshop is this core Kubernetes workshop where it's like you just want to get your application developers up to speed on how to use Kubernetes. The complexity is just astounding. And you need all of your engineers to understand it if they're going to carry the pager, especially a smaller company where your application engineers need to be able to debug issues with their applications in the cluster when things go sideways. They need far more knowledge than you would expect.
So when companies come to you saying that, hey, Tammer and your awesome SuperOrbital team, we need help. We really need help. What do they need help with? Is it training? Is it running stuff? What does that look like?
We don't do, because of the nature of who we hire and how we're positioned, we don't help with maintenance on clusters. We don't help with on-call or upgrading clusters and that kind of stuff, which it just doesn't make sense to engage with us for that kind of thing. But customers definitely come to us for training, and they come to us, like I said, for the harder Kubernetes problems.
Can you give us a few examples, like some hard Kubernetes problems that companies struggle with or teams struggle with?
Yeah, we have a couple of clients who are attacking on-premise installations for their product. They have a product that they run, but they want to deliver it to other companies on-premise in the other companies' AWS accounts or even bare metal or whatever. Mm-hmm. And the interesting thing about Kubernetes is that it is becoming that ubiquitous platform. It is becoming that assumption that you can make that if I'm going to go on-premise, I want to target Kubernetes because that's going to hit the 80% of my potential customers. That's easily becoming the case. And going on-premise is very difficult, even with a substrate like Kubernetes to lean on, because often you get zero telemetry, right? You get no metrics, no logs, no hands on the keyboard. You can't kubectl exec into something and fix it. Usually with these engagements, or usually for our clients, their customers are highly regulated, highly secure companies that have very strong security postures. And so what our clients need is not only to believe that what they are going to be deploying into their customers' Kubernetes environments are well engineered and using all of the best practices from Kubernetes point of view, but often they also need a lot of custom code developed in order to do health checks. For one customer, we actually built a dashboard that their customers can go to and see the health of their application, but also the health of the underlying cluster, basically so that their customers can self-select into, should I file a ticket? Or is it actually a problem with our own cluster and we need to go to our own operations team? That kind of thing is fundamentally important. And when we were at CloudFoundry, we have so much experience with the headaches of trying to ship on-premise that we just naturally, that's why we ended up with all these customers doing it, because we just had that experience already. Another fun example is we had a crypto client who wanted to integrate AWS Nitro Secure Enclaves with EKS. And the Nitro Enclave thing is a really interesting technology where you can run verified code in a highly secure hardware-based environment. It has to be built into the chips on the actual machines that AWS gives you. And even AWS engineers cannot access the memory for that code. But using it is a huge pain. I mean, using it is incredibly difficult. And the code that runs inside this secure enclave cannot do things like network or, anything. You can only communicate with it through this weird VSOC that happens at the kernel level. And so integrating that with EKS turned out to be very challenging. And so they brought us on board to help out with that. And as it turns out, we were, I think, maybe still the only people who have done that integration, the only people who have tied EKS and Nitro together so that you could launch a secure enclave from a pod and communicate with it directly from that pod. And we know that because we actually had to work with the AWS engineering team to get it done. And it was a lot of fun. And we got, we blogged about it, and the engineer loved that work. That's part of the reason why we can attract such senior talent, is because we get to work on the more interesting projects like that.
Right. You've hit so many things, and I'm going to ask one thing, which is very close to my heart. So in CloudFoundry, we knew to use Bosch to manage CloudFoundry.
Yeah.
Is there such a thing in Kubernetes where when you deploy Kubernetes on bare metal, what would you say? What should users or teams use for that management of Kubernetes on bare metal or on-prem?
There's a variety of tools for deploying Kubernetes to bare metal installations. And that's not really the hard part with Kubernetes. In the cloud, there's managed Kubernetes, and that solves all your problems. But that's not the problem with Kubernetes in complexity. In fact, getting a Kubernetes cluster up and running is fairly easy. On bare metal, you have some issues with the networking, but there's projects to solve that. You've got KubeRouter, and you've got MetalLB, and you've got others that solve that problem for you. It's interesting that you brought up Bosch and CloudFoundry. And for those who don't know, the way that CloudFoundry was designed was that we had two different products. We had Bosch, which was sort of a competitor to Terraform and Ansible and Salt. I don't know this for sure, but I think it came right out of the Google's Borg. It's like a rewrite of Borg, basically. And it's very difficult to use, but once you use it, like once you learn it, Stockholm syndrome kicks in and you start to love it. There's huge Bosch fanatics, right? And Bosch was the tool that the operator used to deploy CloudFoundry. Very difficult to use, but very powerful. And CloudFoundry was the interface that the operator then could present to the application developers, which was basically a blatant ripoff of Heroku, which was a great model. 12-factor, build packs, all that stuff made it real easy for application developers. But here's the interesting thing. I refer to that as the Great Wall DevOps model, where CloudFoundry allowed the operator to serve the application developer well by giving the operator this beautiful wall that both sides really appreciated. The operator appreciated how easy it was to manage CloudFoundry through Bosch, and the application developer appreciated how powerful it was for them to manage their application through CloudFoundry. Kubernetes is entirely different from that, right? Kubernetes is what I call the Kumbaya DevOps model, where everybody has to know everything, right? Kubernetes doesn't have the concept of an operator versus an application developer. At best, it gives you some tools where you can kind of build that using RBACs and stuff, but that's really difficult to do. And nobody knows quite where the line is supposed to be. And so everybody does it differently,
Yeah. Okay. So they do have YAML in common. That's still around. That's still paid, but maybe not for long. Who knows? We'll see. So what I'm taking away from this is that Kubernetes is everywhere, and teams, they need Kubernetes because it's the easiest way to get something out there. It's ubiquitous. It's everywhere.
Yeah.
And it handles the complexity really well. So you're right. The 80 resource types, plus all the custom ones that you can install, and typically you get via CRDs.
Yep.
You get even more, and they get even more complicated. It's a great way of modeling some really complex software, whether it's microservices, whether it's stateful services, and that's not fully, but it's getting there for sure. I think there was a maturity level that had to happen at the data services side as well, just to understand that operating model.
It's not just ubiquitous, it's just becoming the standard, right? It's expected that if you're going to, as you said, model out your infrastructure, your application infrastructure, then you're going to do it in YAML using Kubernetes objects, right? So that you can deploy it anywhere.
And there are some really great projects in this Kubernetes ecosystem and in the bigger cloud native ecosystem, which work well together. But it's intricacy of finding the right combination of the objects or the products that make sense to you. And that's where the complexity lies in. So the Kumbaya, anything goes. and everything goes. And by the way, there are teams for which a certain combination makes sense, which would never work for other teams. And that's what gives it the beauty, also the complexity.
It's building blocks, right? The entire community is all about building blocks. And if you have a large enough team that you can dedicate a couple of people to choosing the right building blocks and wiring them all together and producing this really great experience for your engineers, then that's great.
Do you think that teams would be better without Kubernetes?
Yeah. I mean, again, it depends on the size of the team, but I'm going to just ballpark that 30%-ish of people who come to us saying, we're looking to embrace Kubernetes, we're going to move to Kubernetes, and we'd like your training or your help on the engineering side to get it done and to get it done right. About 30% of the time when people come to us asking for that, we try really hard to convince them not to. Because if you're a small startup, then unless you're doing something really complicated, then it's just too much for you, right? I mean, you're not focused on your own innovation. Instead, you're focused on managing Kubernetes. So here's the story. When I was, through most of my life, I've been a Linux user until around 2006, I think it was. And I used to run Linux on all kinds of hardware. I was one of those geeks in college that had a small network of, like Sun and different servers and things like that. And for the longest time, I ran Linux on my laptop as my daily driver. And around 2006, I realized that I was spending 20% of my time trying to figure out how to close my ThinkPad without the kernel panicking, right? It's like about an hour a day, every day, Yeah,
it doesn't want to sleep. Linux doesn't sleep.
Yeah, it just does it. Yeah, it's always working for you, And I just flipped the table. I bought a Mac and I never looked back, right? To me, the analogy is that Kubernetes is that Linux on the laptop experience, right? There's always going to be problems because you're always integrating 24 different technologies to get a full Kubernetes system running. And it's fine if you have administrators there to focus on that task. But if you're, a 10-person startup, that's not where you need to be. You should be on like Heroku or Fly.io or what's the other one? Nitrous or Google Cloud Run, Fargate, like any of those, right?
Yeah.
Are better choices than Kubernetes. The litmus that we give these people when they come to us is stay on these fully managed platforms for as long as you can. And every time an engineer says, we should really use Kubernetes for this, that, or the other, you say, no, we should stay within the confines of a 12-factor app, like as much as you can. You change your product definition so that you can stay within that confine, whatever you can do, until you really believe that you need to provision raw EC2. When an engineer says, look, this is an important feature, the only way we can get this feature done is if you give me the keys to AWS because I need to provision some instances. We're going to configure those instances. We're going to run systemd on them. We're going to tie in all the logging and all the metrics into some sort of centralized system. We're going to have alerting and everything set up and all of that. That's when you say, no. We're never going to provision raw instances because Kubernetes is the future for all things cloud level, all things that would be infrastructure as a service. Instead, you should be using Kubernetes. That's the inflection point.
This episode is brought to you by our friends at Incident.io. Every software team on the planet has to manage incidents, and a very large percentage of those teams are using Slack to communicate. That includes us. With Incident.io, you can create, manage, and resolve incidents directly inside Slack. Here's how it works. Head to Incident.io and sign up for free, then add it to your Slack. From there, you have a brand new incidents channel where all incidents get announced. Use the /incident command to create and manage incidents. This command lets you share updates, assign roles, set important links, and more, all without ever leaving the incident channel. Each incident gets their own Slack channel plus a high-res dashboard at Incident.io with the entire timeline from report to resolution. Get everyone on the same page from the moment they join the incident and help stakeholders stay in the loop. Add Incident.io to your Slack today and prove to yourself and your team that they have everything you need to streamline your incident management. Learn more and sign up for free at Incident.io. No credit card required. Again, Incident.io.
think that you've heard this question many times before, and I still have to ask it. Do you think that Kubernetes would have been as popular and successful was it not for Docker?
Yeah, that's a great question. I mean, obviously, who knows? But from my point of view, I don't think Kubernetes would have gotten off the ground at all if it wasn't for Docker as a standard, right? We all know that Docker as a company, they had an opportunity and they just couldn't quite execute on it. So whatever, that is what it is. But the thing that Docker gave to the technology community is that standard of what it means to be a container. And and we all know that like there were containers before Docker, right? I mean, LXC, there was Solaris zones, FreeBSD jails, sort of, right? And things like Solaris zones arguably were better. If I remember correctly, they ran separate kernels per container, right? But it was that standardization of how you create a container and what a container, or how you create a container image and what a container image actually is, and that allowed tools like Kubernetes to flourish. So absolutely not. I don't think K8s would have been a thing without Docker at all. Which, I mean, I understand that Kubernetes inside Google was Borg and Omega, right? So obviously it existed before Docker existed inside Google, but that's a completely different thing. In order to get community adoption, in order for this open source thing to flourish, if Kubernetes had been built as an open source product and had its own idea of what a container is and had this thing of you have to run these commands to generate an image and then we run it, I just don't think it would have gotten adoption at all. It wasn't just the standardization of Docker too. It was also, frankly, I don't want to use the term hype because Docker is a very powerful and important technology, but there was a wave, right? Where people were just really excited about Docker, and anything that embraced Docker got an immediate uplift because of that. And I think Kubernetes, benefited from that.
Yeah. I remember that age and period really well when you had to run containers. Didn't matter how, didn't matter where, you just had to run containers. And Kubernetes wasn't a thing back then.
So few people even knew what containers were, right?
Exactly. We're like, what? Containers what? Why would you want containers? And I remember FreeBSD jails as well. I'm yet to start a FreeBSD jail successfully. I've started that project when 10 years ago when I got my first FreeBSD server. And I never got to this day to get the jail up and running because how complicated it was.
Yes.
And I started there's so many configuration options, and Docker made it run a command and you have it. That was brilliant. So as an idea, as a concept, was really, really good. And things then they got complicated and, it happened what happened. But you're right, we are here today where Docker is no longer part of Kubernetes. It used to be, and that created quite the confusion.
People say that Kubernetes dropped Docker and it's no longer, but that's my point, is that we shouldn't be thinking about the word Docker. We should be thinking about the standard that Docker created. So Kubernetes is still using Docker as a standard just as much as it did before, right?
Yeah.
It's still an integral part of what it means to be Kubernetes.
I think it's the container runtime. That's, that clarification came afterwards. No, we're not dropping Docker support because Docker means so many things. It became an ecosystem. And even now, the default container registry is the Docker Hub, right?
Yeah.
So if you don't specify, and that's also Docker, it's part of Docker. But also the container runtime, the containerd, runc, and a couple of others. But I think these are the two popular ones. So that's what they meant by removing Docker as a dependency of Kubernetes. And I'm wondering if you have to be good at Docker to do Kubernetes. Do you need any experience with Docker? Do you need to run Docker locally to get Kubernetes? I know that you can get Kubernetes in Docker, which confuses a lot of people. And I'd never recommend it, but
turtles all the way down and turtles in a circle even. Yeah. We actually get that question a lot, especially when we're talking to people about our workshops, because I guess the answer is sort of. You sort of need to be good with Docker in order to be good with Kubernetes. And what I mean by that is, our core Kubernetes workshop actually doesn't use Docker at all. You never run a Docker command throughout that entire workshop. And even when we go under the hood, as you said, nowadays, you don't even see Docker on the nodes because it's all containerd, right?
Yep.
You need to understand the concept of what containers are, as in sort of tiny VMs that can share some stuff. We talk about the Linux namespaces that are being used in Kubernetes, right? When we talk about the different things you can share amongst containers. But you don't have to be great at crafting a Docker file, for example. And crafting a Docker file is an art. It is hard to create an efficient, really good Docker file. and to understand all the security implications and everything. And to some degree, I think that shows how Docker did the tech community a service by giving us the standard, but did us a disservice by making that standard so low level. I mean, as an application developer, you need to understand not only apt get install, but also the apt cache and the difference between Alpine Linux and Ubuntu. All this stuff is kind of crazy. So most successful teams that I've seen instead centralize at least the skill of crafting Docker files, if not just using a single centralized Docker file across all of your applications. That's like a thing you can do, right? So most teams I've seen have centralized that knowledge of how you create efficient Docker files and all that. And then application developers just need to understand, maybe locally, they need to understand, Docker Compose up and maybe a few Docker command line things. And they need to understand maybe how to push Docker images, but frankly, often that's just taken care of by the CI/CD system too. Yeah. So no, I think you can make a lot of use of Kubernetes without having a deep understanding of Docker.
For me, Kubernetes makes a lot more sense, having started with Docker and having spent a couple of years in that ecosystem before Kubernetes was a thing. So, and that's very easy to ignore and forget because my beginning was not Kubernetes, but many people, this is where they start and they miss the whole Docker thing. I mean, they may have been running it locally, but not to the point that they understand it, not to the point that they've been using it for a couple of years and really understand what's happening under the hood. So I think some Docker concepts, and as I mentioned, and as you mentioned, it's not just the runtime. There's so many other aspects to Docker, are really helpful to get started with Kubernetes. What other things do you think are helpful when you get started with Kubernetes?
In terms of knowledge, I think it's almost more important to have a deeper understanding of Linux networking and just networking in general. From our experience, understanding how a cluster IP service works, for example, and all the IP tables stuff that happens there, understanding how load balancers work, understanding why node ports are a terrible idea, or understanding how ingresses work at layer 7, right? All of that is conceptually harder for our students from what we've seen, and conceptually harder for people who are new to Kubernetes because they just have never had to deal with that kind of networking knowledge. I think another thing that's important for a team who's getting started with, well, first of all, let's talk about how you should adopt Kubernetes. First of all, even though I kind of poo-pooed the value of the Kubernetes managed services like EKS, AKS, and GKE, you absolutely should use them. I mean, yes, you can deploy your own cluster, but why? Like, just go with one of the managed solutions. Frankly, they're cheaper, especially GKE, right? Yeah. And if you have a choice, just to, if you have your druthers about which cloud to be on, GKE is by far the best experience, and Azure is by far the worst experience, not just in terms of Kubernetes, but just across the board, right? And AWS is what it is. So if you're on AWS, you're probably forced to be on AWS and whatever, you're on EKS. And then once you've got that, as I mentioned before, there's so much other stuff that has to be configured and deployed on top of that. And our best advice is just to keep it as simple as you can. Most of our customers have already spent so many innovation points when they are adopting Kubernetes. We kind of feel it's our mission, our job to help guide them towards more conservative solutions and fewer moving parts. Because it's so tempting once you've got Kubernetes, like, I guess I need Istio because Istio does all these cool things. It does. And if you need those things, that's great. Jump on board. But holy crap, is Istio complicated? I mean, it's dangerous. I mean, like if you misconfigure Istio, like you can really do damage to your production traffic. And, avoid any tooling that you don't have an immediate pain point for. When you look at the CNCF landscape, it can often look like you're in a toy store. You see all these wonderful, cool gadgets and you just want to grab them all up into your basket. But you need to show a lot of restraint because every one of those that you add is something else you have to manage and understand.
Oh, yes. Yes. Most people forget about that. Like install it and that's it. Well, how are you going to upgrade it?
Right.
And some components don't upgrade as well as others.
Yep.
And then that just opens like a whole new world of problems, like a whole new set of problems. Like, do you upgrade in place or do you stand up another Kubernetes cluster? And if a cluster gets too big, well, should you split in multiple clusters? And before you know it, you're solving problems that you didn't even know existed before you chose Istio. So maybe don't.
Right. Exactly. You're like, where am I?
Exactly. I thought I understood networking. No, you don't.
Right, yeah, when you think you understand networking, then you see how Istio actually works. You're like, oh my gosh. And there are some components that are kind of table stakes for a new cluster, like Cert Manager is a great example of just, okay, everybody should have Cert Manager running in their cluster. But there's so many other things that are cool and interesting, but probably not something you need. Another example is Helm. Helm as a tool is amazing for installing third-party packages, something that somebody else has to maintain, right? You need Postgres, then sure, use the official Postgres Helm chart. That's the best way to do it by far. Well, Postgres is maybe a bad example because there's also operators that do an even better job, right? Mm-hmm. But what I see teams immediately doing, because they just didn't know any better, they just assumed that this is how you use Kubernetes, is they start building Helm charts for their internal applications. Small teams doing this. And Helm, although it's great for package distribution and consuming third-party software, in order to author a Helm chart, you are using a Turing-complete templating language in order to generate white space sensitive data structures.
How crazy is that? Oh my
It's just crazy. It's crazy, right?
I'm glad it's not just me that thinks exactly the same way. I'm glad it's not just me. So I'm not the crazy one. Okay, good. Okay, so I have confirmation that I'm not crazy. Okay.
I don't know about that, but just one aspect, you're not crazy.
Damn it.
Right?
Almost. Almost.
And the sad thing about it is they just don't know any better. They got very simple applications. They're a small team, and they end up spending a lot of time building these Helm charts to make them, to distribute them and stuff. You don't need that. Like Customize, for example, is a great tool for managing your YAML when it's being deployed to multiple environments, because you can make very small changes. Customize is much easier to understand, much easier to maintain. If you're really small, you don't even need a tool like that. You could just apply the YAML and just call it a day, I think when a team chooses Kubernetes, where it should focus on is automation, building out their own internal automation system, not just for managing the cluster using like Terraform, which is by far the best tool for that kind of stuff, but also for managing the resources inside the cluster, a CI/CD pipeline, maybe using like GitOps at the end or whatever. That's the fundamentals that your team should focus on, because once you have that, all the other changes become simpler. And frankly, that automation is the half of the value prop of Kubernetes, because the Kubernetes API is so good. It's so easy to automate stuff through Kubernetes. And if you're not investing in that automation, you're wasting that value. And then obviously, I run a company, so I should say that like if you're just choosing Kubernetes, you should be looking for training. And I love our workshops, obviously, but there's others, right? But you do need to invest in your engineers' knowledge, because they are going to have to debug it when it goes sideways. And you don't want them floundering and using Stack Overflow in the middle of an outage.
Oh, yes.
If you can we offer engineering services, usually not for people who are just now adopting Kubernetes, unless you've got a very interesting application you're moving over. But you should be finding experts, either hiring Kubernetes experts or finding a partner that you can integrate with your team that will give you those subject matter experts for Kubernetes, because you're going to save a lot more time and money in the long run if you do that early on.
What's up, shippers? This episode is brought to you by Sentry. You already know working code means happy customers, and that's exactly why teams choose Sentry. From error tracking to performance monitoring, Sentry helps teams see what actually matters, resolve problems quicker, and learn continuously about their applications from the front end to the back end. Over 1 million developers and 70,000 organizations already ship better software faster with Sentry. And guess what? You can too. Ship It listeners new to Sentry get the team plan for free for 3 months. Use the code SHIPIT when you sign up. Head to sentry.io and use the code SHIPIT. And by our friends at Equinix Metal. If you want the choice and control of hardware with low overhead and the developer experience of the cloud, check out Equinix Metal. Deploy in minutes across 18 global locations from Silicon Valley to Sydney. Visit metal.equinix.com/justaddmetal and receive $100 in credit to play with. Again, metal.equinix.com/justaddmetal.
You've touched on a really important point, namely the investment in automation. So if you use Kubernetes, that's great, especially if you need it, but you will have to invest in automation. And I think there's a set of principles which are really important that you have once you enter this world of cloud native Kubernetes, because otherwise making choices will be really difficult. Automation is really important once you are in the world of Kubernetes, in the world of cloud native.
Absolutely.
What other things are important?
Well, I mean, if you're going to move into that world, again, as we said before, the complication is just massive. I mean, there's so much that you're pinning together, that you're tying together. I think that it's important, if you're going to do that, that you invest in education in your engineers so that they can understand this complexity. And depending on the size of the company that you are, depending on the size of your engineering team, many companies invest in what we're calling internal platforms. And you can just view that as an extension of the automation. It's almost a spectrum of how sophisticated these internal platforms get and kind of what model they use. All the way from, on the lowest level side, is just the platform team providing maybe centralized Docker file, maybe a centralized Helm chart, with as one of the few times we've seen Helm used internally in a good way, and a centralized CI/CD system so that the application developers can plug their app into the Helm chart using that Docker file, and it gets automatically deployed to all the various environments and such. Then on the other side of the spectrum is implementing a full Heroku, right? Where the developers are insulated 100% from the details of Kubernetes, and they're given a really nice interface. We have never seen that done successfully, just to be clear. Like, I've never seen that work where the developers did not still have to understand the intricacies of Kubernetes, because at some point they got to break glass in case of emergency.
Yeah, because you have to run it, right? You've built it, but you have to run it. And guess what? It's running on Kubernetes. So if you don't know how to debug it or even understand what is happening, good luck to you.
And if your platform team is so good that they have actually built a full interface on top of Kubernetes that takes care of all the details, and the application developer only needs to interact with that interface, that platform they built, I've got news for you. You're probably in the wrong industry. Like, you should spin that off and clear house, right?
Oh, you gave me an idea, because even though we use Kubernetes to run all of changelog, the developers, they don't know that. They still just git push. And all the automation takes care of the rest. So we were using Docker Swarm before, and we were using Docker before. The experience, as far as developers are concerned, it has never changed. It has always been git push. Like, isn't that the Heroku experience? Git push and it runs.
That is.
It.
But what happens when there's a fire? How do the developers debug when...
They don't.
Okay.
They don't. So around that, we have a set of services, like, for example, Grafana Cloud, where we send all the logs, all the metrics. So if there is a problem, that's one of the first places where you would look. A new addition was integrating with Honeycomb.
Nice.
And Honeycomb gets the Fastly logs as well, which is the CDN. Because it's not just Kubernetes, it's also what's in front of it, and then what's behind it as well. There's like all these components. So having these different ways of understanding what is happening in your runtime, whether it's Kubernetes or something else, is important regardless what the runtime is. For example, getting exceptions. That's like a really old thing, which we used to do when we used to SCP our Ruby code onto, or FTP it, right? We still used to get like exceptions. I forget like what the name of that tool was. Do you remember what we used back in the day?
There was a number of them. In fact, I actually wrote one of them.
Exactly. That's why I'm asking you.
I wrote Hoptoad, which later became Airbrake and competed against Get Exceptional. And hilariously, both Airbrake and Get Exceptional were purchased by the same person, and now they're actually run under the same umbrella, which is kind of funny. But yeah, you need all these things. You need all these interfaces into understanding what your application is doing. I'm really excited, by the way. This is a bit of a tangent, but I'm really excited by all the stuff that's going on with eBPF, especially with things like, I think it's New Relic's Pixie. So yeah, New Relic's Pixie is really exciting because of the deep insight it can give in a language agnostic way. It's one of those things that you could see as a building block so that the developer does not need access to kubectl exec, for example.
Exactly. That's it. That's, I think, what a successful ops side of like running Kubernetes looks like, where you don't have to get there. Like as a developer, for example, blue-green, right? If you do that properly and if you have like all the redundancies in place, even when something goes down, the end user doesn't see that. And it doesn't matter that it runs Kubernetes. And when it comes to debugging it, well, if you're a small team, and let's say the problem is in Heroku, what happens? Do you debug Heroku? No. No way. You don't get the keys to Heroku to debug over the stack, right? It just gets scheduled somewhere else. And that's how that gets solved. So what I'm saying is having that visibility into how things run is really important. And if that's your experience and your interface, that's great. I think that's one of the principles that are really important regardless what the runtime is. And if it's Kubernetes, so be it.
If you're going to be using something like Kubernetes, you need to invest doubly strongly in observability and in all of that metrics. But I'd argue that you need that just as much, if not more, if you're not using Kubernetes. If you're trying to do raw AWS, for example, it's even harder to build all that observability infrastructure in place.
Yes.
But it's absolutely, if you're just moving into the cloud world and moving into this whole type of world where automation and where it's a cloudy world that's focused on automation, you need that observability, not only for your own ability to debug, but eventually you're going to feed that observability back into your automation, right? Yeah. You're going to do automated blue-green rollouts where you want the automation to, over the course of maybe a day, to look for errors, look for reduced metrics, and to roll it back.
Yeah, that's right. And like, I know that I read like ops and infrastructure and like that side of things, but our Kubernetes setup, it's simple on purpose. And some things could be better. It can always be improved. We have it public. Anyone can check it out to see how we run and how we set up and which components we pick. Cert Manager is part of it. External DNS, if you ingress Nginx. Yes. All the
external
stock
DNS
stuff.
Also absolutely necessary.
Yeah, it's part of it. And the Kubernetes is managed, so we don't deploy on bare metal servers, even though that's become simpler over the years since we embarked on this journey. And there's other options, which we will also be exploring. So whether you do Kubernetes or something else, there will be certain operational concerns which will be difficult. And there's a level of maturity that you need to have on the team to navigate them. And I think that's what is important to almost like reiterate. And in certain cases, like Istio, I'm sure some things it makes better, but networking, I don't know. I think networking gets more complicated with Istio. And if you're okay with the trade-off, maybe it's a good one to make. But I wouldn't. We haven't chosen Istio. So there we go.
I agree with you 100%.
Talking about Kubernetes and how we run it, do you recommend a big cluster or do you recommend smaller clusters?
Oh, yeah. So when Kubernetes first came out, I mean, first of all, short answer is many small clusters. The long answer is when Kubernetes first came out, CIOs looked at it and said, oh, this is great. We can, we're probably using 20% of our CPU and memory across all of our VMs, across our entire fleet, just because of natural inefficiencies between teams, right? Mm-hmm. You need a new app out, you throw a couple of VMs out there, you call it a day. And the CIO's job, part of it, is to reduce infrastructure costs, right? Mm-hmm. And so the CIOs looked around, they said, oh, this is great. We can bin pack the out of this, right? We can take all that stuff and just shove it into one massive cluster, save so much money. And I think that drove a lot of initial Kubernetes adoption. I mean, obviously there was a lot of grassroots adoption of Kubernetes, but there was also a lot of adoption coming out of the IT organizations in larger companies because of that driving factor. Now, when the operators started using Kubernetes, they saw what I think of as the real benefits. I don't think the benefit of Kubernetes is about orchestrating containers. I think it's about that beautiful idempotent, declarative, and ubiquitous API. And especially when you start extending that into external services, external resources that you're managing, like using, for example, Crossplane to provision AWS resources through kubectl, it's a fantastic experience, right?
Mm-hmm. Yes.
And the operators looked at it and said, this whole Kubernetes thing is pretty cool. However, blast radius is a thing, right? Mm-hmm. And so if you got everything in one big cluster, and especially those poor operators who went through the 1.8 through 111 frame upgrade path, got burned so many times on trying to upgrade these clusters in place. And they started developing these complicated blue-green cluster upgrade strategies where they deploy an entirely new cluster. And that's necessary and great. But now we've figured out that, well, you should just be running many small clusters. And there's two different ways you could do it. You run a cluster per kind of bounded context for your microservices. In other words, you could have a cluster just for your shopping cart stuff and a cluster just for your front end stuff and cluster for your back end and all of that. Mm-hmm. But a better way of doing it is to run all these clusters as homogeneous workloads where they are all running identical workloads. In fact, one of our clients is doing that, and they're referring to it as fleets internally. So what they do is actually really smart. They run a cluster in AWS per availability zone. And that does a couple of things. It's a natural dividing point for the different clusters. And it means that they also keep all of their traffic inside each AZ because all the services in cluster A are always talking to other services in cluster A. They don't try and do cross-cluster traffic. And that saves them a good amount of money because they have a lot of networking that's happening in AWS. But also it means that when they're upgrading these clusters, they can just, upgrade one. And if it goes sideways, who cares? Burn it down, rebuild it, and you're fine. You've only lost, 20, 25% of your capacity, and you just keep moving. Now, of course, the big elephant here is state. You can't do that with databases. And so the best solution that we always propose to our customers is, look, if you're going to run stateful workloads in Kubernetes, which, by the way, that's a lot of innovation points. You really need a team to manage that if you're going to do that. That's a dangerous thing to do as a small company. But if you're going to run stateful workloads in Kubernetes, at least shove them into a smaller cluster that you have to treat as a pet. You've taken all of your other clusters, your stateless ones, and you've made them into cattle, which is beautiful. Then you constrain all your stateful workloads into one, or just use RDS. Just externalize your databases entirely, right?
Yeah, it's a tough problem. And unless you've been solving that problem for some years, it's really difficult to appreciate. And even the operators, I'm glad that you mentioned it earlier for PostgreSQL. Do you know how we run PostgreSQL?
How do you?
We run it as a stateful set. No helm, no operator, nothing like that. And since we did that, it's been more stable. It has not failed since we went to a stateful set, simple stateful set, PostgreSQL container, PostgreSQL image.
And what were you doing before that? Were you doing RDS or were you doing?
We tried running the crunchy data PostgreSQL operator, and it failed because of replication. Actually, we even covered this in an episode at length, but the point was the primary stopped replicating to the replica.
Yeah.
So the write-ahead log filled up on the primary. The second, it crashed. The secondary could not be promoted. The replica could not be promoted to primary because it was too far behind. And then we didn't have a database.
Ouch.
And we couldn't reboot the main one because the PVC filled up. We couldn't resize the PVC either. And we thought, let's just crunch data. We actually went to Zalando one, the other PostgreSQL operator, and the same thing happened. So obviously the networking, there was an issue at that point with networking, and that broke replication, PostgreSQL replication, which resulted in a less stable database.
Yeah, but I mean, come on, that's not because of those operators. You would have the same problem running a stateful set. I think you probably changed other things at the same time as moving to a stateful set, or maybe changed the way you use it or something like that.
We don't replicate. Like a single instance.
Okay. Well, there you go.
We back everything up. We back every hour. We do like a full backup.
Yeah.
And we can restore from backup within 2-3 minutes. So a blank node can pull the backup down from S3 and boot up in 3 minutes. We'll have less downtime, and it's a very simple procedure. Now, would I choose a managed?
Right, you've got a potential data loss issue of like up to an hour, right? Half an hour median data loss if you lose the PV, right?
Exactly, yes.
But that's a trade-off that you're willing to make. That's fine. That works great.
Exactly. And if I was to choose any PostgreSQL type of service, I would just go for a managed one, like CockroachDB, something like that. I mean, that's what I'm thinking, because it's a really hard problem to solve. I've been trying to solve this for like a couple of years. I don't think I have in like a different context because it's really difficult.
I got to tell you that I love the solution you just talked about, because too many companies, and I've heard other people say this, not like this is some insight that I have, but I agree with it 100%. Too many companies look around and they see all this really interesting and production grade hardened technologies coming out of Google and Facebook and other companies like that. And they think, oh, okay, well, if we're going to play in the cloud, we got to have that. right? You don't. And if you try and build your system to be at that level, it's going to drag you down with the weight of it, right? And you looked at it and you said, we can, worst case scenario, we lose a PV, we can handle half an hour's worth of data loss, right? It's not that big of a deal. Then you can go with a single instance of Postgres without replication and you are fine and your life is so much better, right? So I love that you had the self-awareness as a organization to make that choice.
Yeah, we don't use PVs, but I don't have time for that story.
Do you use the host disk for that, or what do you do?
Oh, yes. It's like 10 times faster.
Yeah.
Like we never lose that.
You don't care.
Yeah.
So it does mean that like when you're rolling hosts under your cluster, you need to probably call downtime, right? You need to stop
We
traffic.
have a single host. It's so good. It never went down. We have a much better integration with the CDN. And what that means is that even when the origin is down, we serve stale content. And unless you do posts or patches or anything like that, gets, it works. And parts of the website may be down for most users, but you get your MP3s. We'll serve that content. We'll get the pages. And
basically what you're telling me is, boy, life is easy when you're a read-heavy workload. I tell you what.
yeah, it is. It definitely is. And if we were to, for example, if we had to have the database up, I really do think that going to a managed service, regardless who manages that, it's a much better proposal.
Oh, for sure.
All the backups, like all the replication, all that stuff, it's managed. You don't have to do that. And you're just consuming the PostgreSQL interface. That's it. So that sounds like a much better proposal. Like a CDN. Would you run your own CDN? Maybe. I mean, if you're big enough, you'll have to. If you're that scale, sure. Right. And another thing about running databases inside Kubernetes is that you could think of it as almost addicting, because once you make the decision that, well, we're not going to use an external database provider. Instead, we're going to just run them as stateful sets inside Kubernetes. And we believe in the Zalando operator, for example, right? Well, you're going to find that your developers are naturally just going to be provisioning databases. And that's going to result in multiple stateful sets, not, schemas in a large existing Postgres. It's just naturally going to proliferate. And that's the headache that you're going to feel. Is that suddenly we have a client who's got hundreds of Postgreses, and I'm not going to name the client, obviously, but I will say they're running them wrong and they know it, right? It's technical debt that we're helping them dig out of, but it's a huge pain, huge cost for them. Once you get to a certain scale, you're right. Like you have to take a certain approach, but when you're not there, don't take that approach. Take the simpler one. Right. And what this approach means for us is that we can innovate elsewhere, and we can fight other battles. There will still be battles to fight, even if you don't do this one. It doesn't mean that you're like less capable or less curious. It just means you've picked your battles in a way that suits you. And one of these days, as a company, you'll get big enough where you need that more interesting, innovative challenges. And there will be companies like ours to help you out when that happens. But please don't just assume you need that prematurely. There's a similar thing with writing code. I tell you, iterating on a code base, because I've spent half my career as an application developer as well as operations. Iterating on a code base before it's actually launched and in production is so much faster, right? You can make all kinds of schema changes. Like, who cares? Never ship. That's what you're saying. Yeah, basically never ship, and you'll be the fastest startup. So the opposite of the show. Don't ship it. But I mean, it's the same thing. You launch when you need to launch, but you understand the fact that as soon as you launch, you're going to slow down by at least a factor of 2, maybe 3, right? And you increase the complexity of your operations stance, your Kubernetes usage when you need to, and you understand. I mean, even embracing Kubernetes, you do it when you need to, and you understand that much complexity is going to slow you down. Yeah, that's a good one. That is a good one. So I think it's time to wrap up. We can have so much fun. I didn't realize. I think we just have to do this more often. That's the only conclusion again. As we are prepared to wrap up, what do you think the most important takeaway is for our listeners from this conversation? Well, I mean, I didn't think it was going to be this when we first started talking, but I think the most important takeaway is don't use Kubernetes unless you need to. Delay the adoption of Kubernetes. It's going to be on your roadmap. It's going to happen as you grow. But just like anything else, don't try and tackle that problem early. Use one of the existing
managed platforms, not managed Kubernetes installations. Although when you do adopt Kubernetes, do that. But just delay it for as long as you can. And then, even then, understand that you're spending innovation points. So use it in as simple of a way as you can, because you need to pay down that innovation debt, right?
Yes.
Focus on the automation and focus on the education for your people, because you will underestimate how complicated Kubernetes is. You will be surprised when you start using it and start seeing all of the different ways that you can configure it and all the best practices that are not codified in it.
Well, thank you, Tammer, for sharing so much valuable information. And
I had so much fun. This was great. Thank you.
Yeah, I had so much fun too. Thank you. I'm looking forward to the next one. I really am.
Absolutely.
Thank you. Thank you for tuning in to another episode of Ship It. This is just one of our podcasts for developers. Go to changelog.com/master for the rest. You can join our community at changelog.com/community. There are no imposters in our Slack. Everyone is welcome. Huge thanks to our partners Fastly, LaunchDarkly, and Linode. Thank you, Breakmaster Cylinder, for all our awesome beats. That's it for this week. See you next week.